So, good morning, everyone. I hope I am audible to all of you. Hello, yes. Pradnya, Rutuja, Vaishali, Radhika, Annan, Nuja, Ritik, Vishaka, Raj, Shweta, Shwetanjali, Prajakta, Farin, Yemangi, Mansi, Deepak, Meera, अक्षया, जागृती, आकाश, मानसी, उत्कर्ष आत्ताच 2 मिनिटापूर्वी स्टेटस टाकून लगेच येऊन गेली. सायली, प्रणिता, सुप्राप्ती, प्रक्षेप, नम्रता, पूजा, किरण, अथर्व, प्रणाली. Yes, okay. Where are other guys? झोपलेत का? So let's start our discussion. We have started with HPLC detector. Yes, Harshal, Praveen. We have started with HPLC detectors. So first of all, there is a news that one of the toughest exam in India, UPSC, has declared its result, and it is indeed very close to my heart actually. It is one of the exam which gives you a fair chance whether you come from affluent family or a backward family, and that's why this exam is very close. Even the top ranker, you must have heard, Pradeep Singh, is from a very formal background. His father is a farmer. So the only aim is to dream big. Do not get excuses to overcome you. If you think big, if your dreams are big, there are two chances. Either you will get a success or experience. There is no such a word called as a failure. And one exam cannot let you decide what is success and what is failure. But this exam is itself overwhelming and a very informative exam, challenging exam. So whatever may be the aim in your life, whatever may be your dream, do not think that you cannot achieve it. You can achieve it definitely. Just focus more on your dreams. Okay, still there is no hope that other guys will come. Okay, Praveen, Leena, Ajinkya, Nikita, good morning. Let's get started. So tighten your belt. Okay, so in the chat box right now, clear me what is isocratic and this gradient illusion fast. I don't know what is isocratic and gradient illusion. There was a confusion yesterday also. So let's chat in the chat box what is isocratic and gradient illusion. Pooja, good morning. Akash, good morning. Pranjal, good morning. I'm going ahead. Isobatic means concentration of mobile phase constant throughout the process. Okay, Suprapti. What about gradient then? Pratiksha, good morning. Strength of the mobile phase is increased during the separation is a gradient illusion. Good. Akash says gradient variations in composition of mobile phase. Next question. Recall some of the ideal characteristics of detector. Mansi, yes. Okay. Mobile phase of constant composition is called as isocratic illusion. Siley, okay. Neha, good morning. Isocratic concentration, single pump use. Gradient concentration, 2 pumps use. Recall some of the advantages. Ideal characteristics of detector. Eye sensitivity, okay. Non-destructive, good. Prajakta says isocratic means concentration of strong solvent remains constant. Okay. Good stability. The mobile phase composition remains constant throughout the separation procedure, and the gradient illusion is the mobile phase composition is changed. Okay, good. Negligible baseline noise. Radhika, good. Kimaya says high sensitivity. Siddhi says inert, sensitive and specific. Pranjali, good morning. Prakshep, adequate sensitivity. Kimaya, good stability. Okay. Should be non-destructive. Linear response. Okay, good. Mansi, linear response. Utkarsha says reproducibility. Okay. So these are some of the characteristics of ideal detector. Okay, highly sensitive, non-destructive. Now let me know what is selective detectors. Selective detectors. When I say the word selective detectors, what does it exactly means? Highly sensitive, good stability, reproducibility, linear response to the solute, negligible baseline noise, inexpensive, capable of providing information on the identity of the solute, a short response time, high reliability, non-destructive. Mira says UV spectroscopy. Radhika says solute property. Okay, what else? Selective is only for single property. Okay. Akash says selective for only single property. Can you name some of the selective detectors or so called as solute property detectors? And also write its comparison with respect to universal detector or a bulk property detector. Yes, good. Independent of the mobile phase is also one of the characteristic. One particular physical chemical property, but independent of the mobile phase is another characteristics. Good. fluorescence, CAD. What was that? CAD, computer assisted depends on the solute properties of mobile phase. Okay, UV mass. Okay, what about universal? What about universal detectors? Okay, highly good. Absorbance detector, fluorescence detector, electrochemical detector, mass spectrometric detector. Computer aided design. Now comment on universal detectors. Okay, gives result to every component. Refractive index, evaporating light scale. Good. So okay, so this is the universal detector which we need to compare it with this mobile phase composition. It is not independent of the mobile phase, and some of the physical properties we will have to look afterward. The difference in some physical property of the solute independent of the mobile phase compared to the mobile phase alone. Excellent. Refractive index, yes, and evaporating light scattering detectors, you have already mentioned it. Okay, so this is all we have completed with the detectors list. What is sensitivity? Now let's start with UV visible detector. Sensitive in the sense majority of the organic compounds which we are dealing are totally or called as a partially shows absorbance in case of UV or a visible range. If you completely consider this UV and visible range in totality, you come to know that majority of the organic compounds will show the absorbance in UV visible region, and that's why this is sensitive for each and every product, because there is always absorbance maxima for every organic compound irrespective of the other compound. That means it is distinct and unique for every organic compound. Okay, and that's why it is a sensitive instrument. Wide linear range, no doubt to say that 200 to 800 nanometer is itself a very wide linear range where almost most of the organic compound will show its absorbance. Okay, unaffected by the changes in temperature. That is what the basis of your analysis, rather classification of UV visible detector in a single property detector, or what we call it as a selective detectors or solid property detectors, because they are unaffected by the changes in the temperature. That doesn't mean the variation in the temperature may last for 40 degree, 50 degree, 60 degree. Variation in change temperature means 1 degree, 2 degree, 3 degree. That is what the change in the temperature. Now the change does not affect as such UV visible detector, because it is one of the robust instrument which we already have handled it, and it is also not affected by mobile phase composition. Remember, the one of the leading cause of UV visible detector to be used widely, had a wide applicability and wide acceptance, is not just because of the simple operation, but just because it is unaffected or remains stable in the changes in the temperature system also, and it does not have any effect with respect to the mobile phase composition, just because we can easily eliminate the mobile phase absorbance by comparing it with the blank. Okay, when your sample has been compared with your mobile phase composition that could be treated as a blank, you can easily determine or you can easily negate the effect of mobile phase on the detector system, and that's why it is widely applicable, widely accepted detector system. Remember, these are some of the advantages with respect to the UV visible. It is sensitive, it has a wide linear range unaffected by the changes in the temperature, and more importantly, mobile phase composition does not affect its detective capability. Principle, as we all know, the UV visible principle is what? Lambert's and Beer's law. A is equal to epsilon BC, or is simply called as A is equal to ABC, depending upon whether units which you have going to check. In case of absorptivity, is it a specific absorptivity or a molar absorptivity? Okay, so this law is very familiar to us. At a constant cell thickness and constant wavelength, remember, if you achieve the constant cell thickness, which is always a 1 centimeter, as we use the sample cell, or they call it as a cuvette, which is of 1 centimeter, what we can say, internal diameter, and if you maintain the wavelength so that your absorptivity for that compound will be constant. So if this is constant, then this absorbance is directly proportional to the concentration. That is what the Beer's and Lambert's law is all about. Okay, Lina, no issue. It's raining heavily outside actually, so there may be chances that network issues will be there. Okay, good morning. So what I mean to say, if you maintain the constant wavelength in the sense absorptivity, and cell thickness, that is B, means epsilon and B will remain constant, so absorbance is directly proportional to concentration. This we already dealt with Beer's or Lambert's law. Which is that law which says that absorbance is directly proportional to the concentration? Is it Lambert's law or Beer's law? Absorbance directly proportional to the concentration, and there is another law which says that absorbance is directly proportional to the path length. So what is the law which says that absorbance is directly proportional to the concentration? Is it Beer's law or is it Lambert's law? Yeah, Akash replied fast. It is a Beer's law, ABC. Okay, so that says all about the UV detectors. Now, depending upon the wavelength which you choose, okay, Amar says also Beer's law. Good. So, depending upon the wavelength you choose, there are 3 variations with respect to the UV visible detectors. Remember, when we say narrow range or a wide range of detection system, in case of UV visible detectors, you come to know that the variation in the wavelength can be possible, and you can go for, yes, Beer's law. Good. You can go for a fixed wavelength also, you can go for a variable wavelength also. Now, what are the advantages with respect to the fixed wavelength and what are the disadvantages with respect to the variable wavelength? That is what we need to study it. Fixed wavelength, as the word suggests, fixed wavelength means it operates only at a 1 wavelength. Remember, if you say if you fix the UV visible range, yes, Beer's law. Good. If you say it is operates at a particular wavelength, just like as we have performed the practical of assay of paracetamol. Take the example of it. So assay of paracetamol, the paracetamol shows absorption maxima at 257 nanometer. That means we have done the detection of paracetamol at a particular wavelength only, that is 257 nanometer. This may be 254 nanometer or anything else which you have already. So that means it operates only at a single wavelength or a one wavelength, that is fixed wavelength. Now if anyone acting on the single wavelength will definitely show the overall precision which is the best enough. Remember, when you are studying the analysis only, take an example, when you say that you study only analysis out of the 6 subjects, your precision and accuracy towards the subject is manifold higher. But when you are dealing with multiple subjects like Sutics, Cognosy, Ecology and so many other subjects, your precision will definitely going to decrease day by day, and we can consider that you have to manage all the subjects in an appropriate manner so that every subject will look like a what we can say covered enough. Due to this, if you are dealing with the multiple objects or multiple subjects, your precision will definitely going to decrease. And if you are dealing with a single object or a single subject, your precision level will be high. Now same way, if you are dealing, if your UV visible spectrophotometer or a detector deals with a single wavelength only, it shows the highest amount of precision capability. Best overall precision is noted for peak area measurements as compared to variable wavelength, because peak area measurement is what forms the basis of our this HPLC resolution system. Now this, for quantification purposes, if you go for a single or a fixed wavelength detector system, you will get the best precision, and that's why the area measurement in case of this detector system will be higher and the quantification will also be higher. Okay, but it itself uses the discrete source, because when you are using single wavelength, its source must be unique, distinct, and that's why the sources, the light sources or radiation sources which are used for fixed wavelength detectors are a low pressure mercury lamp which may emits 253.6 nanometer, which is close to 254 nanometer. Depending upon your fixed wavelength, you will have to choose the distinct source, radiation source, which we have already covered in the last semester. Okay, so if you are choosing somewhere 254, 256, so since to have a maximum amount of sensitivity, you choose the mercury or radiation source which emits the wavelength closer to our analytical wavelength, that is 254 nanometer. So in this case, low pressure mercury lamp which emits 253.6 nanometer will show you highest precision capability. Apart from this, silicon photodiode light detector can also be used in case of these fixed wavelength detectors. It can also be used by other wavelengths by filtering the emission source to give other lines. Remember, these sources, these discrete sources can also be used for other wavelengths also, but just you need to attach the filter so that the appropriate amount of absorption will be possible for appropriate amount of wavelength, and the other wavelengths may get emitted out of the system and you will get the definite source. But the amount of intensity and amount of accuracy and precision with respect to their particular wavelength, I am talking about the source. If the source will have appropriate wavelength which is of 254 nanometer, it does not show you appropriate accuracy at wavelength apart from 254 nanometer. There is a possibility that the source which shows you accurate precision at 254 nanometer can also helps you detect the 300 nanometer wavelength also, but the accuracy at 254 nanometer is highest because the discrete source itself emits 254 nanometer at a higher range or a higher intensity as compared to 300 nanometer, and that's why this affects your analytical procedure. Now second is variable wavelength. Okay, yeah, as the word variable itself suggests, variable wavelength detectors uses the continuous source of light. Okay, it uses the continuous source of light. Continuous in the sense it emits multiple amounts of wavelength ranges or wavelength series, not just like your fixed wavelength sources, where your light mercury or low pressure mercury uses only single wavelength system, though the capacity to alter the wavelength to the different wavelength system can be possible in case of fixed wavelength system, but the intensity with which the other wavelength present in the source is very low as compared to the variable wavelength system, and that's why variable wavelength system uses continuous source of light with a variable wavelength. Now what are the sources? Deuterium or xenon lamp or tungsten lamp. Deuterium or xenon lamp or tungsten lamp will be the source of choice. Desired wavelength is isolated from monochromator. Now fixed variable wavelength doesn't mean that you must not concentrate on a single wavelength. That means you have a variety of wavelength available with you, and you just have to pick the appropriate wavelength, and to choose the appropriate wavelength they use a monochromator. Okay, so that you can have a monochromator, that means a single wavelength out of this continuous source of light which contains a multiple or variable wavelengths. Remember this, the source for this is deuterium, xenon lamp and tungsten lamp. Improved sensitivity from occurring at the lambda max of the solute of interest. Remember, solutes sensitivity or other solutes lambda max can be improved just because of its sensitivity, because you are dealing with a single lambda max. Now as I compare it with the fixed wavelength, its sensitivity is a little low. It is not so sensitive as compared to fixed wavelength, because fixed wavelength is dealing with a single wavelength system. Now in this case, though you are dealing with the monochromator, and as we already said in our last session or even in the last semester, that a monochromator does not guarantee you that 100% of the wavelength which is emitted out of the monochromator contains the 100% wavelength of your interest. There are chances that 99.7%, 99.9% of the wavelength will be of your interest, and remaining 0.2, 0.3% is their impurities. Okay, now as we compare with the fixed wavelength, its sensitivity is definitely can be improved, but not that much as compared to the fixed wavelength. Remember, fixed wavelength will show you the highest amount of accuracy, sensitivity and precision. Drawback. Now the lamp which we are using in case of variable wavelength has a limited lamp lifetime as compared to mercury lamp which we have used in case of your fixed wavelength variable system, fixed wavelength detector system. The drawback in case of this variable wavelength system is that it yields, or its lamp does not yield appropriate lifetime wavelength variation, because as soon as you go on using the lamp, its sensitivity decreases, and deuterium lamp will last only for 1000 to 2000 hours. This is what the lifetime of your deuterium lamp, okay, as compared to the mercury lamp. Now in case of fixed wavelength system, you will have a single wavelength, but variable wavelength detectors allows you to have a simultaneous estimation. That means you can set two wavelengths at a time and carry out the simultaneous estimation, because variable wavelength consists of a wide range of wavelengths. You can select two wavelengths of your interest at a time and carry out the simultaneous analysis of two absorbing components by using variable wavelength detectors, which will not be possible in case of your fixed wavelength detectors. Or you have to go for changes in the fixed wavelength system, so that you can have first analysis at a first wavelength, then complete the first wavelength analysis, go for a second wavelength analysis, and this way you can have the data of two components, but the two components requires double the time which can be taken by the variable wavelength system, because you can have simultaneous estimation. Simultaneously you can analyze the components on two wavelength at a time. Okay, so this dual wavelength detection feature useful for simultaneous monitoring of two substances. Baseline noise is higher because this feature is achieved by toggling the monochromator between the two wavelengths. If you are dealing with the two monochromators, two wavelength at a time, in case of simultaneous monitoring, the baseline noise is higher as compared to the fixed wavelength, no doubt about it, because monochromator will not be sensitive enough to allow the two wavelengths of a very 100% purity. Okay, so there are chances that this baseline noise can be possible, maybe because of the monochromator light, maybe because of the impurities present in the sample, but the baseline noise in case of simultaneous estimation is higher as compared to the fixed wavelength detectors. Okay, this is how this optical bench of UV detector works. This is the deuterium arc lamp. I am going to zoom it. Deuterium arc lamp illumination lens, these are the slits which allows a single passage of your light. Okay, these are the gratings, so called as a monochromator. Out of these beam deflecting apparatus which allows the single passage of your monochromatic light. Now the beam splitter will split the reference cell and sample cells beam, and that's how this flow cell, taper cell force flow cell of HPLC allows the passage of reference sample and samples slide also, and you will get a photodiode detector which will detect the concentration or rather identification of your resolved separated components. Okay, so this is your variable. Okay, next is photodiode array detectors. It uses the charge coupled diode array with 512 to 1024 diodes. Remember, these facts can be asked in case of your GPAT. So in case of photodiode array detectors, the diode array are in the number of 512 to 1024 diodes capable of spectral resolution of 1 nanometer. Remember, the spectral resolution, that means separation of wavelengths, two wavelengths will be possible by 1 nanometer. Okay, because of using multiple diodes. Okay, multiple diodes allows you the higher spectral resolution. Earlier they suffered from a sensitivity problems, which has been solved by advanced flow cell design using the fiber optics technology to extend. Let me know what you understand by the term fiber optic technology. It is there in your physics 12th or 11th, I don't know exactly, but what is this fiber optic technology? So they have resolved the problem of sensitivity with respect to this PDA, photodiode array, by addition of flow cell design using the fiber optics technology to extend the path length without increasing the noise or chromatographic band dispersion. You must have heard this term called as a fiber optics technology. Perform simultaneous measurement of absorption as a function of analysis time over a chosen wavelength range, so we get the spectrum. Yes, Nitish, excellent. Waves passage in a zigzag manner in the fibers. Okay, but that term has been called a single term in case of physics. You must have read it in the light chapter, that zigzag manner. Suppose this is the optical fiber. I will show you in the next that zigzag passage is called as total internal reflection, okay, TIR. This total internal reflection is called as a zigzag motion used to transmit the data. Yes, optical fiber network is using. Just because it uses the zigzag motion, it leads to the extension of the path length, okay, it extends the path length, and due to extension of the path length, they does not increase the noise and chromatographic band dispersion, because when optic fiber allows the passage of light or your signal through this, it causes the multiple reflection, total internal reflection, TIR, and due to which the path length gets increased, and that's why its sensitivity get increased. So on this basis, the flow cell design has been modified to give you the appropriate and sensitive photodiode array detectors. Used for the method development where lambda max of impurities of the drug is unknown. This specialty in case of this PDA is that it is used where you are not sure that impurities are present or not. Apart from this, the impurities may affect the analysis, and even if you don't know what should be the absorption maxima in case of impurities, in that case this photodiode array detectors can be used. Every compound can be quantitated at its lambda max, so the trace analysis can be possible. Apart from impurities identification, trace analysis, trace means quantifying the analyte, okay, how much of the quantity of analyte will be present in the resoluted sample can be easily identified, because we all know if you know the lambda max and then absorption, then you can easily quantify it, okay. Compounds not resolved chromatographically can sometimes be resolved spectrally. These photodiode array detectors can helps you to resolve some of the components of chromatographic mixtures which are not so resolved by chromatographically, because you know the lambda max of impurities now, you know the lambda max of your analyte now, and if the resolution will not give you appropriate peak for impurities, then by using the spectral techniques like this, you can easily identify and easily resolve what is impurities lambda max and what is trace analytical or your analytes lambda max. That means compound not resolved chromatographically can sometimes be resolved spectrally. Molecular absorption spectrum can be used for the peak identification of the peak tracking. As we all know, if you have any identified peak with respect to the lambda max, you can go for molecular identification. Yes, used in communication, yes. So molecular absorption spectra can be used for peak identification and peak tracking. You can have the references with you in case of molecular absorption spectrum, and you can easily identify what should be the peak of your analyte and what should be the length and absorption maxima for that particular analyte. So this is photodiode array detectors. This is how it works. Let me zoom it again. This is where this D2 lamp is located, flow cell. At this stage, the sample or rather rays goes out of the sample cell, then this mirror allows the deflection. These slits, we all know what is slits. Then this gratings has been allows the single component which shows the maximum absorption to be get detected at this particular diodes, okay. So this is. Now if you have any compound which does not show chromophore, or it does not possess a chromophore, okay, so in this case, when the solute of interest does not possess a chromophore, then that case indirect photometric detection can be possible, but this is a rare technique in case of UV detection system, okay. If you don't have that compound which do not give you a chromophoric functionality, it is difficult actually to detect the such a compound. Mobile phase possesses the chromophore and absorbs the light. Remember, in this case there is a mobile phase which possesses the chromophore apart from the analyte, and hence it absorbs the light and it will show you the peak. Now in indirect photometric detection, what will be the case? When analyte without a significant chromophore passes through the detector cell, the absorption by the mobile phase, remember who is going to absorb the UV light? It is the mobile phase. Now the absorption of mobile phase is decreased and is recorded as a negative peak. Remember, the absorption by the mobile phase has been set to such a level that it has to be decreased, and you can calculate it as a negative peak, and as compared to this negative peak you can calculate the chromophore's peak. But this is a tedious and not so sensitive method as compared to what I have already said, that derivative spectroscopic methods. In that case, if suppose this chromophore do not yield you or rather your analyte or a solute does not have any chromophore, then after resolution by HPLC you treat it with a chromophore, okay, which will show you UV absorption, okay, which will show you the UV absorption by just adding or a chemical treatment of solute with that chromophore. You will have that absorption where this chromophore, which will get attached after separation, will show you the absorption, and then you can easily calculate what should be the quantity and what should be the quality of your photometric detection. This is another method when your chromophore or rather solute does not contain the chromophore. So these are some of the UV cutoff wavelengths, as we already dealt with it, that some of the solvents may shows absorption. I hope our time has been over actually, so we will deal it tomorrow, okay. So just go through these slides or this video also to understand the UV detection system. We will complete it and start with the refractive index detectors in the next slide, okay. Next मतलब कल, tomorrow, okay. It's 10:42 already, okay. So I think that's sufficient for today, okay. You will deal it with the dealt it in tomorrow, okay. So let me wind up. Again, thank you for watching. Have a nice day to all of you. Take care.